Okay. I think that we should start with this event. Good afternoon and good evening for people from Vietnam to this event. This webinar has been organized on a topic, on a theme of mechanical engineering, today and tomorrow, talking about automation, automotive, electrification. I am Alessandro Capra, delegate for internationalization of University of Modena and Reggio Emilia, and I'm honored to chair this webinar. And we will start very soon with our speakers. And just some announcement. First of all, we will record the webinar. So if someone doesn't want to appear, please switch out the video and cancel your name in case of your intervention. Otherwise, the speakers are prestigious, are very expert in their fields, and they are a very short curricula and the short bio notes are already put on the website, so you can read about the different speaker on this. So we start with the first speaker, is Professor Francesco Leali. Is full professor of design and methods of industrial engineering at Unimore University, and he will talk about the name. The title of his speech is Automotive Research and Education: Challenges, Opportunities, and Novel Models of Cooperation in the Italian Motor Valley. Please, Francesco, it's up to you.
So thank you, Alessandro. I hope you have the possibility to see my screen shared, and just to give you some ideas about what's happening today in the automotive market, in the job market, and also at the university. We have more or less 10 minutes, so we have to run very fast, but is useful for us, so we are ready to do that. Anyway, you know that we are in the middle of a great revolution in automotive, and there are many aspects that we have to consider today in order to plan our future activities as educators, but also as professionals in automotive. Here you can see some keywords that tell us what's happening today about the climate change and the need to reduce the pollution, the air pollution in particular, and all the regulation that are affecting today design and manufacturing of vehicles. We are facing also a trend in the urbanization, so creation of big cities all around the world, and so we have to change our way to move in our spaces. And cities are more and more smart, and vehicles has to be connected in every moment to cities, to the infrastructures, to the roads, and have to offer people very important experiences in driving, in controlling vehicles. And also people aging, especially in the western part of the world, is an important keyword today, is an important topic that we have to face, that we have to treat, and we have to solve using technologies that help people in driving and help people in their mobility. And on the other side, also industry is changing very, very quickly, and we have to consider many new technologies that can help us as engineers to face the new challenges we have. If we stay on the vehicle, on the production and design of high-performance vehicle in particular, but let me say all the kind of vehicles that we are used to know and to discuss every day, we have to consider some trends from a technological point of view. Vehicles are more and more IoT devices, always connected, and are full of devices for driver assistance in order to help and to increase the safety on board. but we have to develop and study also new solutions for powertrains in order to reduce emission, in order to reduce the consumption, in order to increase the performance with respect to the environment. And we have to exploit new technologies as machine learning, artificial intelligence that can help drivers in order to move better along the roads and to increase the performance of the vehicles themselves. Lightweight design, vehicle electrification, human-machine interface are other important keywords that you have to consider in our programs, in our educational programs in particular. And well, the revolution is so deep that at the moment is also very difficult to foresee what is going to happen in the next future. I like very much this chart because it gives us a clear idea of what's the situation today in innovation in technology. It's very difficult to understand which are the technologies that we are going to use in the next 5 years, 10 years. Very difficult for us, for companies, for people all around the world. That's why we need to prepare a sort of super students, people able to know many topics, mechanics, but also electronics, automation control, IT, people able to discuss within multidisciplinary teams with about economics, about medicine, about law, about science, and to integrate using a vision based on the system of the vehicle to find solution to problems that we don't know really today. So it's very difficult to understand well, how is the next future student, the next future professional in automotive. And also soft skills are so important today because we are going to work in teams. We have to stay with people. We have to face problems together to other people and other professionals. So it's very, very, very important. And due to the fast change that we have today, we have also to be prepared to the long life education. So when you ask from the university, when you ask from a master degree program, when you ask from a master program, well, you just are starting a new life in companies, a new life in industry, but you have to be prepared to work every day on different problems. And we know very well it in the Italian Motor Valley. We are in the north of Italy, in a region very, very popular, but also very lucky from a certain point of view, because you understand that in very few square kilometers, we have a very high density of people working in automotive. And we have some of the most important brands in the world. I like to tell the names in our list because it's impressive to think that we have Dallara, we have Maserati, Ferrari, we have Lamborghini, Ducati, Marelli, Pagani, we have Alfa Tauri Formula One team, we have HPE Coxa, that is an important tier one in automotive. So a very high density of people in a region where automotive is part of our DNA, is part of our everyday life. And that's why for us is so important to propose new models and to propose new way to collaborate between universities and companies in particular, but together with the institution and with the regional system. And that's why 4 years ago, we proposed a new model, a model based on a very deep cooperation between private and public entities. And we created Unimore, the Motor Vehicle University of Emilia-Romagna. You can visit our website where you can find all the information about it. But just to give you something from a general point of view, we created, together with the companies I listed before, 3 master degree programs where professors are both from university and from companies, and programs are established and discussed together with the companies in order to create the profile for the next future. What we obtained at the end was a list of curricula, a list of profiles that we are going to develop in the next years. As you can see here, we have the core is about mechanics and is Advanced Automotive Engineering. AAE is the name of the master degree program, where we have many different profiles from high performance car design, racing car design, advanced motorcycle engineering, advanced sports car manufacturing, that is Industry 4.0, and advanced powertrain. And again, we created, starting from the last September, a master degree program on electric vehicle engineering, EVE, that is focused in particular on the design of full electric vehicles. And last but not least, obviously, advanced automotive electronic engineering. The 3 master degree programs are offered by the 4 universities of our region, University of Modena and Reggio Emilia, University of Bologna, University of Parma, and University of Ferrara. And students have the possibility to move from one university to another one according to the best competencies and skills offered by the different sites. And students have also the possibility to move in the company labs to have their own experiences and to deepen some specific aspects. So again, collaboration and partnership with companies is one of the pillars that we consider together with the learning by doing approach. So the possibility to learn in working on a real project, working on real design and manufacturing experiences together with the companies. So as I told you, students have the possibility to visit the companies, to stay with the management of the companies in order to discuss about their skills, about their opportunities. And that's a very important point for us. Today, the call for admission are opened, so it's possible for students from outside Europe to apply in order to be selected. As you can see here, we are looking for top students for the top companies we have. But if I have just 1 minute more, Alessandro, I would like to share with our guest a short video of a couple of minutes.
Please.
So let me stop for a while the presentation in order to share with you the video.
Can you imagine the cars and the motorcycles of the future? Will they be connected to everything? How will their design change? How will the engine of tomorrow work? Maybe motor vehicles will turn on just with a glimpse, or be as fast as your thoughts. The truth is that imagination requires talent, but above all, skills and training tools that only a great university can offer. This is the reason why Mooner, the Motor Vehicle University of Emilia-Romagna, was born. A campus as big as an entire region, with the brands that made the history of the automotive industry and the main universities of Emilia-Romagna merge together to design the 7 automotive engineering careers of the future in electric vehicle engineering, advanced automotive electronic engineering, advanced powertrain, advanced motorcycle engineering, advanced sports car manufacturing, high-performance car design, racing car design. All of them under 3 master's degrees with an innovative learning by doing approach. The most famous automotive companies in the world put their know-how and the most innovative technologies at the service of students to train the engineers of tomorrow directly through their professionals. With Mooner, the most talented students will shift from designing to testing within the most renowned manufacturers with the skills of those are already pursuing the future and bringing it forward. Start here and keep writing the history of 2 and 4 wheels. If you are an engineer with passion for automotive, if you have strong skills and a multidisciplinary curiosity, join Mooner, the University of Motor Vehicle that will drive you in the future. Find out more at motorvehicleuniversity.com.
So thank you, and obviously I remain available for any question, I guess at the end of the webinar.
Yes, thank you very much, Francesco. And like you said, if someone has some question, we leave time at the end of all the presentation, and please write your question on the chat or ask at the end of the 5 presentation. Thanks a lot. And now we are going to the second speaker. Marco Pierini is professor of machine design at University of Florence, and he will talk about teaching and research in the field of motorcycle safety. What new skills are needed for mechanical vehicle engineers? Please, Marco.
Thank you, Alessandro. Just a second, I'm going to share my screen. Can you confirm that you can see it? Can you see it?
Yes, we see.
Okay, thank you. So once again, good afternoon or good evening, everyone, especially the ones connected from Vietnam. As already said, my name is Marco Pierini, and I belong to the University of Florence. In the next few minutes, I will talk about this topic that you can see, that you can read on the title. Before that, just to let you know where we are. We are located in Europe, of course. You probably are well aware. This is Italy, sort of aircraft carrier within the Mediterranean Sea, and Florence is located here, which is just a few kilometers south from Modena, from where Francesco was talking before. We are midway from Milan and Rome, approximately 300 kilometers south of Milan and 300 kilometers north of Rome. And the city of Florence, the University of Florence, the city has about 400,000 inhabitants. And the university, which was originally established in 1321, which means that we are celebrating our 700th anniversary, has currently about 53,000 students for, of course, different disciplines and coming from many different parts of the world. As said, I will focus my presentation on the skills. What are the skills that are needed for the future mechanical and vehicle engineers? And I have decided to make an example talking about motorcycle, and especially about motorcycle riding. This is because riding a motorcycle is very, very popular in Italy, but I know that it's also very popular in your country, and I think so we can understand each other pretty well. And why is important to improve the safety of motorcycles? Because despite the convenience of using a motorcycle, we know that it's also very, very dangerous. And every single year in the world, millions of people die in crashes, in road crashes, and among them, motorcycle riders are, of course, vulnerable road users. Therefore, we can check the problem from a different point of view, starting from crash analysis or using different technology. And in the next few minutes, I will go through some of them just to give you an idea of what type of skill you need to develop to check this problem, to solve these problems. Let's start from the beginning, just an example. If you would like to use your knowledge to solve these problems, you must start from the analysis of the real crash. You have a crash between a motorcycle and a car, and you need to understand the causation, why these crashes occur. And in order to do that, you start collecting information, you investigate the vehicle, and then eventually you can reconstruct the accident. And what type of knowledge you need? You need to have good knowledge in mathematics and physics, but you also need to have a specific knowledge in structural engineering, which allow you to understand at what speed the motorcycle impacted the car in order to produce this type of damage. And then once you have understood the causation, and you may desire to reduce the injuries of this type of crash. And therefore, for instance, you can desire to develop a new type of helmet which protect the most delicate part of the human body, which is the head. And in order to protect the head, you need also to understand how the injury occurs on a brain. So you need to have information, you need to have knowledge on the biomechanics of the injury mechanism. And in order to develop the helmet, you need, of course, to acquire knowledge in computer simulation, because nowadays, when you design a new device, you are always using simulation. But you also need to test the material, because inside the helmet, you would like to include a soft material, for instance, a foam, which is supposed to reduce the injuries in case of an impact. And once that you have developed your helmet and you have your first prototypes, you may desire to test them using a drop tower, so a machine that lets the helmet hit an object and measure the acceleration that you have in a fake head. So what type of skills that you need? You need information or skills in materials, material testing. You need, of course, to have knowledge in machine elements if you would like to design this new machine. And as I said, knowledge of biomechanics and computer simulation are also compulsory. But then you may desire to develop other type of protections. For instance, you would like to protect the leg of the rider by means of lateral airbags. And once you have simulated the system and you have decided the sides and how to inflate your airbag, you need also to test experimentally the system. And so you do not only need to have simulation skills, but also testing skills are very, very important. Then let's move to the future, to the current and future of vehicles, which is the so-called ADAS, which stands for Advanced Driver Assistance Systems, or systems which provide further information to the rider and that let the vehicle interact with the others. These systems are mainly based on sensors like radar, LiDAR, cameras, which allow the vehicle, your vehicle, let's say this one, to detect the vehicles in front of you, a car, a truck, and so on. And when you have detected them, you need to develop the algorithm to let the vehicle know that the vehicle in front of you is braking, for instance. to the rider, and eventually, if necessary, also braking the vehicle on its own without the intervention of the rider. And once you have developed this system, you may need to test it. And where do you test it? You may need to test it on a road open to the traffic, but usually before that, you need to test on a track. And in order to perform the test, you need to install a lot of sensors on the rider, on the vehicle, accelerometers, gyroscope, GPS, pressure sensors, and so on. And you also need to have basic knowledge, at least, of electronics, because these sensors provide information, signals that must be acquired by acquisition systems. So you must be able to have a system which acquires this information for you and to manage it. And suppose that you would like to perform a test with different type of motorcycle and different type of users in order to understand the performance, for instance, in an emergency braking maneuver. In order to do so, you need to have also understanding on the human behavior. So even if you are an engineer, you need to have at least a basic knowledge of the cognitive functionality of the brain and the behavior of the user. And this allows you, for instance, to understand the difference between a beginner's or novice rider or an advanced or an expert riders. Or you may perform what we call naturalistic studies, which consist of installing a lot of sensors in a large number of vehicles, 100 vehicles, 1,000 vehicles, and providing vehicles to normal users, which can use these vehicles for normal life, going to school, going to the university, going to work, and so on, which allow you to collect a big amount of data, what we call big data. But once you have all this data, you cannot analyze them manually, but you need to develop your own proprietary programs to automatically detect the different behaviors. For instance, when someone is braking, or when is overtaking, or when is cornering, and so on. So also programming skills are very important together with the human behavior skills. And last, the future of vehicle development is also very much based on simulators. You have track simulators, you have car simulators, you have also motorcycle simulators. And this technology is using more and more techniques like machine learning and artificial intelligence in order to interact with the user and to adapt to the user. So also knowledge of this technology, which are typical of the sector of informatics, are very important also for a mechanical engineer nowadays. Okay, that's it. I tried to stay within the 10 minutes. I hope that I gave you a little understanding of what skills you need to have for the future developing of vehicles. And I will be, of course, available for questions, if any, at the end of the webinar. Thank you for your attention.
Thank you. Thank you very much, Marco. And thanks for the time. And there is some question maybe at the end of the presentations. Now, next one is Francesco Frendo. Is a full professor of machine design at University of Pisa, and the title of his presentation is Mechanical and Automotive Engineering, New Challenges for Safe and Sustainable Transport. Please, Francesco, up to you.
Okay, thank you, Alessandro, for your introduction, and welcome everybody. Please confirm that you can see my...
Yes.
Okay.
Perfect.
So Pisa is located about 100 kilometers from Florence, is just in the middle of Italy, and maybe you already know it by its Leaning Tower, or as being the native city of Galileo Galilei. And I would talk about recent development in automotive engineers. And today we have to consider that a vehicle is a complex system with a high technological content in different engineering areas. So we have mechanical and aerodynamics, electronics, propulsion made by conventional internal combustion engine or electric powertrain, and we have control system that dialogues with all of these systems. And the challenges for new vehicles are summarized by these three keywords. So vehicles will have to be safe, green, and smart. I will give you some idea of these first two keywords. So with respect to safety, this picture shows the strong improvement in passive safety, which was made possible by mechanical design in last 20 years, 25 years. You can see the results of a CAP test of the same kind of car in the 90s and of a today car. We can appreciate the integrity of the cell where the driver is inside. Yes, but maybe the greatest actual transformation in the automotive field is represented by the introduction of electric vehicles. So this picture gives an idea of the global annual sales of all kind of passenger cars and light-duty vehicles. We can see that we have about 70 million car sales each year. And we can see how the sales of electric vehicle will increase in upcoming years. Okay, but we are engineers, so we have to be curious and we have to do some technical evaluations. So I try to do an exercise. So what are the reasons of fuel consumption and the reasons of emissions? So maybe you already know, or maybe not, but we have three sources of power consumption, which are represented by rolling resistance or road grade and aerodynamic resistance. So this is the sum up of three contributions, and this is why we need about, for passenger cars, 4 to 5 liters of gasoline or 100 kilometers. There is another kind of power consumption which is due to vehicle acceleration. So if we change the kinetic energy of the vehicle, we need power. And if we make some evaluation for a typical car of about 1,200 kilograms, going from standing up to 50 kilometers per hour in 5 seconds, we can evaluate the required power, average power, for each of the previous contribution. For the grade, I consider a road grade of about 5%. So we can see that we have about, let me say, 30 kilowatt, which is needed for acceleration and some less power for the other sources. And if we relate to 5 seconds of vehicle movement, we achieve the energy. Then, are these energies lost? Yeah, the first 3 contributions are lost. I mean, rolling resistance, road grade, and aerodynamics. Actually, road grade maybe not, because we can recover some potential energy, but for sure, the acceleration is converted into kinetic energy and can be recovered by regenerative braking. So this is an important contribution, as you can see, that the engineers have the opportunity to recover. And another point is how much energy is inside a conventional vehicle. If we consider the calorific value of petrol, its density, and the volume of a usual tank, we get that inside a common vehicle, we have about 400 kilowatt per hour of energy, which is the content of about 800 conventional car batteries or 50,000 conventional batteries which are inside our phones. This is intentionally critical. If we consider fictitious power, I mean, if I consider the time that I need to put this energy into the car, so we have 400 kilowatt per hour in 60 seconds, I will get a huge amount of power, which is about 25 megawatts, which means 8,000 times the installed power in our civil houses, and about 1% of an electric power plant. What about electric vehicles today? We have to recharge the vehicle by this kind of recharging station, which have in Italy at least about 40 kilowatt of power. This means that it's about 1,000th of the previous fictitious powers that I considered. So if I want to put the same energy into the car, this means that I need about 9 hours. Yes, but this is not true, because I have to consider that electric powertrains have a better efficiency with respect to internal combustion engine cars. And overall, I estimated that the efficiency is about twice, considering the electric motor and the transmission. So instead of needing 400 kilowatt per hour, we need about 1/4 or 1/5. This is referred to, for example, a well-known electric car. So with this energy and with this recharging power, we need few hours for recharging the battery. We can reduce fuel consumption and emissions also by reducing the vehicle mass, since the mass appears in every contribution, with the exception of aerodynamics losses. And we can reduce the mass by proper material selection or by geometry optimization, by making a proper design of components. We can reduce fuel consumption also by aerodynamics and You can see in this picture how, thanks to modern methods for engineering, the front spoiler of a Formula One car changed in the last 30 years. We have also to consider that, that there are modern production technologies, I mean additive manufacturing, and the future engineer will have to choose among different production methodologies, considering the complexity and quantities of components to be manufactured. In this last picture, I show some example of complex simulation which were developed under the student thesis at our university in cooperation with, in this case, with Piaggio companies, which is nearby Pisa. And the simulation are related to handling, comfort, and structural integrity and durability. So, what expertise should future automotive engineers have? And the answer is simple, but we have to reflect on this. So the future engineer will have to deal with mechanics, aerodynamics, testing, electronics, information, and so on. So what we try to do at our university is to give strong basics in engineering. And these are my concluding remarks. Pure electric vehicles will increase their penetration onto the market, and conventional vehicles are currently being replaced by hybrid vehicles. Mechanical and automotive engineers will dispose of powerful design methods and new technologies, but they have to possess strong knowledge in engineering basics and to have multidisciplinary skills, and they will work in a competitive and dynamic market. So I thank you for your attention. This picture is related to the Formula SAE vehicle developed at our university. And you can find more information about the bachelor's and master programs at our university on our website. So I'm available for discussion after the web, at the end of the webinar. Thank you for your attention.
Thank you. Thank you very much, Francesco. And please, can you leave? Okay. Right. Perfect. And we had, please, you switch out your micro. Okay. We had 3 speakers from university, and now we are changing the scenario. We are going to the private company, to the industry, and specifically we have Dr. Andrea Genuini. He's General Director of Bonfiglioli Vietnam and the Country Manager for Bonfiglioli Southeast Asia. The title of his Bonfiglioli Vietnam is Engineer Lead. Please, Andrea.
Good afternoon and good evening to the people in Vietnam. Thank you for the introduction, Alessandro. Today, I'm going to give you a short presentation about the Bonfiglioli Group and our collaboration in Vietnam with universities. Bonfiglioli is a company, Italian company founded in 1956 by Mr. Clementino Bonfiglioli. And today, Mr. Clementino is not there anymore, so his daughter, Sonia Bonfiglioli, is the chairman of the group. Bonfiglioli is today one of the leading manufacturers of gearboxes and electric motors in the world. We employ approximately 3,700 people in the world. In this slide, you can see the main milestone of the company growth from 1956 until today. Of course, we don't go through all of these milestones, but I want to focus your attention on 2-3 important milestones. 1975 is important for us because Bonfiglioli acquired a company called Transmittal, based in Forlì, near Bologna. And today, Transmittal is the company that accounts for approximately 60% of the company turnover, the group turnover. The second important milestone is 1999, when Bonfiglioli decided to go abroad and to start a production outside Italy. In those years, everybody was going to China, and Bonfiglioli decided to go to India. And it was a winning bet, because today India is one of the most important markets for us. The third one is the inauguration of our new headquarters called EVO in Bologna. This happened in 2019. EVO is the headquarters of the company, but is also a factory where we produce gearboxes, and is a modern factory following the Industry 4.0 concept and self-sufficient from the energy point of view. This is our worldwide presence. You can see that being Italian, of course, we are more present in Europe, but our presence is also very strong in Asia, with 3 factories in India, and then China, Vietnam, and then a branch office in Singapore, and so on. Total, we have 14 production facilities around the world, 21 branches, and over 550 distributors partners. We are organized in business units. We have 3 business units in the group. What we call discrete manufacturing and process industry is basically industrial application, accounting for a little more than 30% of the company turnover. And then the second one is mechatronic and motion system, accounting for 5% of the company turnover. And the last one, the largest one, mobility and wind industry, approximately 60% of our turnover. On the bottom part of this slide, you can see the turnover from 2015 until 2019, and the geographical distribution of this turnover. You can see that the EMEA area is still the most important area for us, but also America accounts for 200 million euro in 2019, and Asia Pacific more than 260 million euro. A little more detail about our business unit. We start with the mobility and wind, which is the largest one. We divided this in 3 sub-business units. The first one is called mobile. Here we provide gearboxes for mobile equipment, so all equipment that can move, and like, for example, excavator, like tractors, like drilling machine, concrete mixer, and so on. The second one is called electromobility, and here we supply gearboxes and electric motors for electric vehicles. And for us, electric vehicle means vehicles like not automotive, not cars, but forklifts, for example, or even excavator today are becoming electric, and also tractors are becoming electrics. The third one is wind. Wind, we are worldwide leader with more than 35% market share in the world. And so this is very, very important today. The second business unit is mechatronic and motion system. Here we produce inverters, servo motor, and precision gearboxes, low backlash gearboxes for industries where the repetitivity and the productivity is very important. For example, packaging industry or textile industry, wood processing industry. The third one, the most traditional one, is the industrial business unit. Here we cover all the other industries that you can have in mind, like food and beverage and tobacco, rubber, plastic, steel, material handling, wastewater treatment, and so on. In Vietnam, we have a large factory, 22,000 square meter plant on a plot of almost 94,000 square meters. So we have plenty of space for future expansion. We have an installed capacity of more than 450,000 electric motors per year in one shift, and approximately 39,000 gearboxes per year. We employ more or less 200 people in Vietnam. These are some pictures of our factory in Vietnam, and you can see that the standard of the factory is absolutely equal to the factories that we have in Europe. So we don't compromise on quality. Here, the product that we make in Vietnam, mainly we make electric motors, because Bonfiglioli Vietnam is the manufacturing hub for the group for electric motors. So I1, I2, I3 motors, so different efficiency class for the motor, motors for electromobility, and motors for wind, also with permanent magnets. And also gearboxes, helical gearboxes, but also planetary gearboxes. Mainly in Vietnam, we produce for export. So we export our goods mainly to Europe. Almost 55–60% of our goods go to Europe, 20% go to India, and 10% goes to China. The rest is spread across America, Southeast Asia, and South Africa. Our collaboration with university. The collaboration of Bonfiglioli Vietnam with university started in 2016 with this collaborative agreement for consultancy between the University of Modena and Reggio Emilia and Bonfiglioli Vietnam. And based on this agreement, the university gave classes to our people in Vietnam on two topics: electric and electronic measurement and electric circuits. So the university provided 364 hours of training to 7 people on these two topics. After this, we continued engaging people from university from 2012 to 2021 in different topics. You can see mainly supply chain and production, but also finance, engineering, R&D. And we work with several universities, as you can see from this slide. The most intense cooperation is with the Eastern International University, where we engage people in internship programs. Last year, for example, we took a couple of students for a technology pillar. We have a Bonfiglioli production system, so we develop internal project for continuous improvement, and we ask the student to support us in these activities. For example, this year we are working together on a project for the reduction of the non-value added activities in the stator area of the electric motor. So the students are supposed to relay out the area and also to study tools for simultaneous tighten of screws. We also sponsored a lab at the university. So Bonfiglioli donated portable testing cases, a smart conveyor, and a triple axis robot. The purpose of this was to allow the student to practice and become familiar with the programming of our inverters and using servo motors and precision gearboxes. Last but not least, we organized several seminars and training supported by us. So you can see many attendees, many people involved in these classes. Often are our managers, the manager of Bonfiglioli Vietnam, who give class to the students. So we organize the space, the room in our factory. They come and we give them a full program, and then they have also the opportunity to visit the factory. That's all from my side. I hope this was little interesting for you, and so you can understand better who we are now.
Thank you very much, Andrea. It was interesting, absolutely. And now the last but not the least presentation, we asked and we found for a testimonial. It means Dr. Yen Jap. She studied in Italy and currently is working as project sales manager at a Royal Group of interior and construction field. So she's a designer. And the title of presentation is Study in Italy Gives Me a New Life. So I repeat, it's a testimonial we wanted to have with us. And please, Yen, up to you.
Thank you, Alessandro, for the introduction. And hello, everyone. And thank you, Bonifiglio and Unitalia for the invitation for me today to have a chance to share my experience with the students, those who are interested in going to Italy to study. And now I would like to introduce about myself. My name is Yen. I'm currently working as a project sales manager at Royal Group in the field of interior and construction, but I'm not a designer. I work mainly for business development. And I used to spend 2 years in Palermo University in Italy and major in Italian linguistics and culture. And I graduated from Hanoi University. Besides, I took several courses of human resource management and business administration at Ho Chi Minh University of Economics. I have been fortunate to earn lots of experience as an Italian interpreter or tour guide speaking Italian. And mainly, I work with projects coordinated between Vietnam and Italy, like projects about Vinasat, Villa Sera, B Group, JBS Italia, or Alax Concorde. Anyway, it's in a large range of work with projects of 2 countries. And how to say, the study in Italy gave me a lot of lessons, not only about the language or the culture, but also the Italian thinking and way of working. That helped me to get involved quickly with the Italian working environment and gave me self-assured to work with Italian experts all over the world I meet at my work. It's all because Italian school got me in a very open and friendly environment. That's helpful for my personal growth in observation, creativity, and critical thinking. And why I chose Italy to study, I was reluctant. And then after my study a little bit, and I see that Italy, is a land of a lot of products, quality products, as from ceramic, glass, interior design, architecture, cooking, fashion, technology, and surely that brings lots of job opportunities with the top quality of the world. For now, the job of business development manager, I have been working in the field of architecture, interior materials. As you know, that the construction in Vietnam now keep growing hugely, especially in hospitality and residential projects. And the market demand of the quality interior is increasing too. As a matter of fact, Italian design never dies. And in addition, Vietnamese are always more interested in Italian exclusive interior. That brings about lots of business in here in Vietnam and also the jobs. For example, there's a lot of Italian or international architecture firms or representative brand offices or commercial companies for interior, Italian interior, etc. Yeah. in conclusion about my experience, Italy anyway brings good things. Believe me, good luck to all of you. And if you have some questions, please send to me at the end of the presentation. Thank you.
Thank you very much. And
my pleasure.
Now we should leave time for question if the attendance participants wants to do directly or by chat or by phone. Yeah. Probably everybody have been too clear. And there is no question, only time to subscribe to our university. Why not? Okay. If the speaker want to add something, or please,
Alessandro, just to say that if I'm not wrong, that the presentation will be made available.
Yes, sure. Thank you, Marco. And the recording of the webinar will be put on the website and will stay for 30 days on the website managed by ICE, by IC and the CRUI. And in the meantime, all the presentation in PDF format will be available for the registered people to the event. Thank you, Marco. Okay, we received some thanks from the attendance. Okay, I think the webinar is finished. So probably for all the speaker, leaving the presentation on the website, probably in the next days, should happen that someone will ask you something. Should be interesting to do this, and maybe in the meantime to ask some bilateral meeting. I'm talking with a colleague of the three university, Unimore, University of Modena Reggio Emilia, University of Florence, University of Pisa. Probably through your email, someone should contact you, and even Andrea Genuini of Bonfiglioli maybe should happen. So please take care about this overall in the next 2 weeks, I suppose. And even for Yen, if some Vietnamese, some people from Vietnam should ask you something about your experience, maybe. And I really thanks all of you for the really interesting presentation you did, and for the time you dedicated and you spent for this webinar. Really thanks, and hope to see all of you as soon as possible. Bye-bye.
Thank you.
Bye.
Bye. Thank you.
Bye-bye.
Thanks to all the participants. Bye-bye.
Thank you.